this lesson, we will learn about finding equivalent ratios. Let's start with just a little review of what we talked about yesterday. So a ratio is a comparison of two quantities. Now we can have two different types of ratios. One ratio is a part-part ratio, and this is where you're looking at or you're comparing two sets within a whole set. You could have a part-whole ratio, which is comparing a set with the whole. And so there's two examples of this where we have three different shapes: circles, triangles, and squares. And if we were going to compare the circles to the squares, this of course is one set, and here is another set. We're comparing those two sets together. They're both part of the whole, but we're comparing the two parts to each other. So that would be a part-part ratio. And if we have a part-whole ratio, we're comparing a part of the set, which in this case is the triangles, to the whole, all the shapes within that set. And so a part-whole compares a part with the total amount. And then again, we talked about the different ways to write ratios. If we were using the two variables x and y, it would be x to y, or we could use the colon, x colon y, or it can be written as a fraction, x over y. So I like this phrasing up here for how to say it. For every blank, there are blank. If we were looking at the squares and circles, for every 4 squares, there are 2 circles. For every 3 triangles, there are 9 total shapes. And we talked a lot yesterday about how the order of your ratio is very important. Which order the numbers are listed needs to have a direct correlation to the items being compared. So if we're comparing triangles to total shapes, then the number of triangles must be listed first, and the total number of shapes must be listed second. So today we're going to talk about finding equivalent ratios. And so we're going to use some vocabulary like equivalent ratios, simplest form, and greatest common factor. When I say those vocabulary terms, you might be thinking back to the things that you learned earlier this year in fractions and even last year with fractions. And some of it's going to seem a lot the same, but when we are dealing with fractions, we can make equivalent fractions. We can make fractions that are equal to each other. We simply multiply the numerator and the denominator by 2, and 2/4 is equivalent or equal to 1/2. So just to kind of wake up your background knowledge of what equivalent means. Simplest form, we can write a fraction in simplest form, and to do this, we find the greatest common factor that both the numerator and the denominator share, and we would divide by that greatest common factor, and so we would get 1/2 is equivalent to 4/8, and 1/2 is 4/8 written in its simplest form. So a lot of these same concepts are going to apply as we start talking about ratios. So think about that background knowledge that you have for those terms from when you studied fractions. And even though ratios are a bit different than fractions, we're going to apply some of those same concepts. So in looking at this first situation, it says Jack has 4 red apples and 8 green apples. The ratio of the number of red apples to the number of green apples is 4 to 8. So 4 apples for every 8 green apples. We're going to look at some equivalent ratios using these same apples, and equivalent ratios show the same comparisons of numbers or quantities. And so let's look to see what that means. So here it tells us that Jack puts 2 apples of the same color on each tray. So we still have our same number of apples. We still have 4 apples, and we still have 8 green apples, but they're just packaged differently. So he puts 2 of each apple in a package. So he has 2 trays of red apples, and he has 4 trays of green apples. And each tray equals 1 unit. So there are 2 trays of red apples and 4 trays of green apples. So that ratio, or the number of red apples to the number of green apples, in this situation would be 2 to 4. Now he still has our 4 red apples, and we still have the 8 green apples, but this time he's packaging them in groups of 4. And so he has 1 tray of red apples, and he has 2 trays of green apples. And again, each tray is considered 1 unit. And so we saw on that previous picture that 1 tray of red apples and 2 trays of green apples, well, the ratio that's being shown there then of the number of red apples to the number of green apples would be 1 to 2. So now let's look at these 3 ratios that we just talked about. The first one we looked at, there were 4 red apples to 8 green apples. Then when we organized them into groups of 2, let's come back and look at that. When we organized them into groups of 2, we had 2 trays of red apples to 4 trays of green apples. And then when we arranged them into groups of 4, we had 1 tray of red apples to 2 trays of green apples. So these are comparisons. They're comparing the same number of red apples and green apples. So we would say that these ratios are equivalent ratios. 4 to 8 is equal to 2 to 4 is equal to 1 to 2. And this ratio, 4 to 8, in simplest form is 1 to 2. Now we're going to talk a little bit more about how to make these equivalent ratios and how to find the ratio in simplest form in our next few slides. Before we look at how we find those equivalent ratios or find the simplest ratio in simplest form, let's look at one more example where we have a set and we are changing the grouping of the set to make equivalent ratios. So let's look at these pencils compared to the push pins. So we can see that there's 1, 2, 3, 4, 5, 6 pencils, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 push pins. So the ratio of the number of pencils to the number of push pins, remember the order really matters here. So pencils to push pins, think it in your head. What would that ratio be? Hopefully you said 6 to 12. And now we're going to change the grouping. So we still have 6 pencils, but now we've put them into groups of 2. So when we put these pencils into groups of 2, we have 3 groups of pencils. And when we put the push pins into groups of 2, how many groups of push pins do we have? Did you count 6? So the ratio of the number of pencils to the number of push pins in this situation would be 3 to 6. Okay, the same number of pencils and push pins are being represented. We've just put them into groups of 2. Okay, finally, let's say we put them into groups of 6. Okay, so all 6 pencils would be in one group. So there's one group of pencils. And if we put the push pins into groups of 6, we can see that there are 2 groups. And so in this situation, the ratio of the number of pencils to the number of push pins would be 1 to 2. Now, all of these ratios that we've just listed are equivalent. Let's take a closer look at that. So the ratios that we talked about were 6 to 12, 3 to 6, and 1 to 2. So let's just list those out so we can look at those. 6 to 12, 3 to 6, and 1 to 2. So in these equivalent ratios, the ratio in its simplest form is 1 to 2. That's the simplest way to write it. And the ratio that shows the actual number of pencils to push pins, that's that original one, right? This shows the actual number. And so it would be the ratio of 6 to 12. So let's start talking now. How do we find mathematically a ratio in its simplest form, and how do we find equivalent ratios mathematically? Well, let's start by first talking about writing a ratio in its simplest form. To do this, we need to use the greatest common factor that the two terms share. So in this ratio, 4 to 6, we have two terms, 4 and 6. So here's our friend reminding us down here, to write the ratio in simplest form, you have to divide the terms by their greatest common factor. So let's do a little review here. I would always start with the first term, and I would list the factors for that term. So remember, factors are two numbers we multiply to get a product. So the factors of 4, and you always start with 1. The factors of 4 would be 1 times 4, 2 times 2, and since we reached 2, we know we're done finding its factors. So the factors of 4 are 1, 2, and 4. Okay, so now I would start with my largest factor and see if that is also a factor of 6. So 4 is a factor of 4, but 4 is not a factor of 6. Nothing times 4 equals 6, so we know we're not going to use 4. Let's move on to the next biggest factor, 2. 2 is a factor of 4 because 2 times 2 is 4. And 2 is also a factor of 6 because 2 times 3 is 6. So we know that the greatest common factor we're going to use is 2. So we are going to divide both terms by 2 to put this ratio in its simplest form. So here are our terms, 4 to 6. So if we take 4 and divide 4 by 2, we get 2. And if we take 6 and divide 6 by 2, we get 3. So 4 to 6, the ratio 4 to 6 in simplest form would be 2 to 3. Now, our friend down here says, the numbers 2 and 3 cannot be divided by a common factor other than 1. And that's how we can tell that a ratio is in its simplest form, when the terms only have 1 as a common factor. And so 2 and 3 only share a factor of 1, and that's how we know it is in its simplest form. So the ratio 4 to 6 in simplest form is 2 to 3. Let's try another one together, and then I'll let you try one on your own. So if we had the ratio 12 to 4, and we wanted to write it in its simplest form, the first thing we need to do is find the factors for the first term. So let's list the factors for 12. Notice how I followed that very careful order of starting with 1 times 12, then I moved to 2 times 6, then I moved to 3 times 4, and I know I'm finished because my next one I would try would be 4, and I already have 4 in my list, so I know I have all the factors of 12. Now, we're going to start with the biggest factor and see if it is also a factor of 12. So can we multiply 12 times anything to get 4? No, we cannot. So we cannot use, or 12 will not be the factor we use to simplify. Can we multiply 6 times anything to get 4? No, so we can't use 6. Can we multiply 4 times anything to get 4? Yes, yes we can. So the greatest common factor of 12 and 4 is 4. So we're going to divide the terms 12 and 4 by 4. So if we divide 12 by 4, think about what we'd get. And if we divide 4 by 4, what would we get? Did you get 3 to 1? So in simplest form, the ratio would be 3 to 1. And we know it's simplified because the only factors that 3 and 1 share are 1. And so that tells us it's in simplest form. All right, you try this next one. The ratio is 9 to 15. So your first step is to find the greatest common factor between 9 and 15. I would start by listing the factors for 9. Start with the greatest one and check to see if it's also a factor of 15. You can pause the video and check back in to see if your thinking matches mine. So when you list the